Right now, I mean, literally as we speak, beneath the dirt of the American West and the Midwest, there is just this massive $2 billion puzzle spread across vast stretches of land.
Oh yeah, massive is almost an understatement.
Right. And the engineers who are tasked with building it are facing what honestly might be the most intense logistical constraint on the planet. I mean, they have to completely dismantle the old puzzle, build a vastly more complex new one, and they have to do it without ever turning the system off for a single second.
Yeah, it is the ultimate high-wire act of engineering.
Yeah.
We were talking about an infrastructure project so enormous that it literally reshapes the geography it sits on. But the crazy thing is, it's designed entirely to, remain out of sight.
Exactly. Well, welcome to the deep dive. We are so thrilled you're joining us today because we are looking at something that is just staggering in its scale. We're unpacking the colossal engineering and logistical reality behind modernizing America's strategic deterrent. Specifically, we're looking at the new Sentinel system. And for this, we are drawing from a really comprehensive briefing by Northrop Grumman titled Peace Through Power.
Yeah, and to really understand what is happening here, you have to look at the historical and the strategic context first. For nearly 70 years, intercontinental ballistic missiles, or ICBMs, they've been this sort of ultimate backstop balancing the global scales of power. But the goal of the Sentinel program is not just to drop a new weapon into an old silo. The intent here is to create what Northrop Grumman calls an unblinking eye.
An unblinking eye.
Right. It's a comprehensive system that's engineered to remind adversaries of the consequences of an attack. 24 hours a day, 7 days a week, 365 days a year, never blinking.
Right. And just to, set the parameters for you listening, we are looking specifically at Northrop Grumman's engineering roadmap for this program today. They position this as the backbone for the nation's security for generations. And we are not here to take sides on global nuclear politics or, debate deterrence theory.
No, not at all.
Right. Our focus is strictly on the mind-bending logistics, the physical footprint, and just the wild technological innovations required to actually build this thing.
Which is where you have to fundamentally shift your perspective, I think. To grasp Sentinel, you really have to stop visualizing a singular rocket sitting on a launch pad. You need to start thinking about a massive continent-spanning network.
Let's unpack that network then, because moving from the abstract theory of, strategic deterrence to the actual concrete and steel reality of it is where the numbers just get completely dizzying.
Oh, absolutely.
I mean, the Sentinel program links more than 450 missiles and silos. It connects launch centers and wing command centers across several states. And to even just initiate this, there's already an investment of over $2 billion in cutting-edge facilities and technology.
Just to start.
Just to start. And they've hired a workforce of more than 5,000 people strictly to advance this specific project.
And all of this is moving on a really accelerated timeline. The engineering goal is achieving initial operational status in the early 2030s. So the challenge isn't just the sheer volume of material or capital, it's what they call a system of systems.
Right, a system of systems.
Yeah, that massive workforce and the capital investment, it illustrates a profound shift in how we view defense. This is a domestic infrastructure and really an employment undertaking just as much as it is a military one. You're building the roads, the highly secure communication trenches.
As testing facilities.
Exactly. The testing facilities, the command nodes, and these vast data networks that actually allow the physical missile to function in the first place.
It's wild. The scale reminds me of an impossible urban planning challenge. It is basically like being asked to completely remodel and upgrade an entire major city's power grid. So you're laying all new cables, you're building new substations, swapping out the generators, but you are under strict orders that the lights cannot flicker.
Not even a little bit.
Right, not even for a millisecond while you do it. I mean, this is not an assembly line spitting out a product.
No, that is an excellent way to frame it. You are terraforming a defensive network while it is actively defending.
Which I guess brings us to the actual hardware going into these silos and trenches. Because if you have a 70-year-old concept like the ICBM, how do you actually modernize it for a 21st century battle space?
Well, the engineering intent relies on a generational leap in what they call digital modular design.
Okay.
And this modularity, it applies to the entire ecosystem, the infrastructure, the networks, the battle management, and of course, the LGM-35A Sentinel missile itself. which is being designed for unprecedented accuracy and range.
Right, and that word modular is the key to the entire physical architecture here.
It really is.
But I actually want to push back on that term just a little bit.
Oh, how so?
Because when I hear digital modular design, it immediately sounds like the way a tech company pitches, like a new smartphone,
Yeah.
Buy our modular phone, you can swap out the camera in 2 years.
Right.
For a system this critical, is it a bit jarring to think about a nuclear strategic deterrent having a modular update path? Like, you don't exactly want an operator saying, hold on, I'm just downloading the latest software patch for my ICBM.
I mean, yeah, it does sound a bit like consumer tech jargon at first, but there is a deeply pragmatic engineering reason why modularity is essentially the holy grail for a weapon system of this magnitude.
Okay, lay it on me.
So if you look at the history of 20th century military hardware, these systems were highly bespoke and tightly integrated. The software, the hardware, the guidance systems, the propulsion, they were all inextricably linked.
Right, it was all one big package.
Exactly. So if a crucial targeting component became obsolete, you often had to tear the entire system apart or, honestly, just design a completely new missile to replace it. The downtime was massive, and the cost was just astronomical.
Which directly violates the primary rule of the unblinking eye. You cannot have massive downtime.
Precisely. You can't just turn it off. So by utilizing a digital modular design, engineers are decoupling the components. They are building a physical and digital framework where specific modules, say, a new sensor array or an upgraded communication node, can just be swapped out over the next several decades without taking the entire silo offline.
Oh, wow.
Yeah, or without rebuilding the network.
Mm.
If a radically new guidance technology is invented in, say, 2045, you don't build a new ICBM. You isolate the old module, swap in the new one, and the system seamlessly integrates it. It drastically controls those long-term maintenance costs, and it really accelerates the timeline for upgrades.
So it is essentially future-proofing the hardware.
Exactly. It ensures the deterrent remains credible against evolving threats without requiring a multi-billion-dollar teardown every single time technology advances.
Okay, that makes a lot of sense. But a state-of-the-art, modular, highly accurate missile is basically a titanium paperweight if the humans in charge cannot securely and instantly communicate with it.
Oh, 100%.
Which transitions us perfectly from the physical missile to the network that commands it. A modular design doesn't mean anything if the launch command takes 5 seconds too long to reach the silo.
Right, which brings us to the physical connection between the operators and the hardware, and this is just a massive leap forward from the legacy systems.
Yeah, this detail completely stopped me in my tracks when I was reading the brief. To facilitate this communication, Sentinel is laying down what they call a future-ready fiber backbone.
Yeah.
We are talking about more than 5,000 miles of ultra-secure, lightning-fast fiber optic network. 5,000 miles.
It's hard to even picture.
It is. To put that in perspective for you listening, that is roughly the equivalent of laying down a private, hyper-secure internet cable from Los Angeles to New York and then almost all the way back again.
Just for this one system.
Exactly. It is a massive trenching and laying operation across rural America, dedicated solely to this one deterrent system. But here's my question. Why undergo the logistical nightmare of burying 5,000 miles of physical cable? I mean, we have highly encrypted, advanced military satellite networks. Why rely on something you have to literally go out and physically put in the dirt?
It is a really great question, and it basically comes down to two critical factors: latency and survivability.
Okay.
So in the realm of strategic deterrence, latency is your absolute worst enemy. Even a delay of a few seconds for a signal to bounce to space and back, it's just unacceptable when you're dealing with, modern hypersonic threats.
Right.
The physical infrastructure has to match the speed of modern digital decision-making. We are talking about the latency requirements of a high-frequency trading firm, but applied to global security.
Oh, man. So physical fiber optics provides that near-instantaneous zero-lag connection that even low Earth orbit satellites just struggle to guarantee.
Yes. And then there is survivability. Satellites can be jammed. They can be spoofed. They are vulnerable to anti-satellite weapons and space-based interference. But a physical, closed-loop fiber optic network buried deep underground, that is incredibly difficult to disrupt without a direct physical kinetic strike on the American homeland. It ensures near real-time status monitoring and command control that is completely isolated from the outside digital world.
Which leads us directly into where all that data is actually going, right? The command centers.
Exactly.
The engineering roadmap details 3 reimagined, state-of-the-art wing command centers, and they actually have the construction of the first one already underway at F.E. Warren Air Force Base.
Yeah, and these centers are fundamentally different from the legacy infrastructure.
Yeah.
The focus here is on being the true nerve centers of deterrence operations, because modern deterrence is entirely about information superiority.
Right, and for an audience that, follows military tech, it is pretty obvious that a 21st century command center is going to process data. But what fascinated me here isn't just that they have computers, it is how the network aggregates the data to essentially eliminate the fog of war.
Exactly. I mean, these aren't just thick concrete bunkers where operators sit at analog consoles waiting for a red phone to ring anymore.
Right, totally.
Because of that 5,000-mile fiber backbone we just talked about. These wing command centers function as incredibly advanced, low-latency aggregation hubs. They are pulling in millions of data points across the entire system.
Wow.
Like security sensors at the silos, internal diagnostics of the missiles, network integrity metrics, and it's synthesizing all of that into a real-time, integrated picture.
So the wing leadership has instant, perfectly reliable data to assess the status of the entire deterrent just at a glance. It must drastically enhance decision-making speed.
That is exactly the goal. They're designed to give human operators perfect situational awareness to make decisions that, carry global consequences in fractions of a second.
Okay, so we have the modular missiles that can be upgraded over time.
Yep.
We have this sprawling 5,000-mile private fiber optic network buried underground.
Right.
And we have these high-tech data aggregation command centers. So you are building this highly integrated system of systems. But here is where we hit the ultimate logistical nightmare.
The transition gap.
Yes, the transition gap. How do you swap out the backbone of the nation's security without leaving a temporary gap in your deterrence?
You can't exactly put up a BRIB sign.
Right, exactly. If you have to take old Minuteman missiles offline to install the new Sentinel infrastructure, to lay the new fiber, to update the silos, aren't you inherently vulnerable during that multi-year window? If the primary systems are offline for an upgrade, what actually happens?
Yeah, and that is widely considered the single most critical vulnerability in any nuclear modernization program.
Yeah.
As we established earlier, you just cannot put up a closed for renovation sign.
Yeah.
You cannot afford a temporary drop in readiness. And the engineering solution to this is what the program calls the secondary launch capability, or the SLC.
Right, the SLC. It is designed to ensure survivability and effectiveness even in stressed environments. But what exactly is the SLC doing that bridges this gap?
Well, the secondary launch capability functions as an incredibly robust, interoperable failsafe.
Okay.
Historically, secondary launch systems have often involved highly secure mobile or airborne command nodes that can step in if the primary underground launch control centers are compromised or, taken offline. But the true genius of the new SLC isn't just that it acts as a backup during a theoretical attack.
Yeah.
Its primary engineering triumph is solving that exact transition nightmare you just highlighted.
Really? How does it do that?
By acting as a universal translator and a bridge. The secondary launch capability is engineered to be interoperable with both the existing legacy Minuteman weapon system and the entirely new Sentinel weapon system simultaneously.
Wait, seriously?
Yeah.
Oh, wow. So it can securely handshake with analog technology from the 1970s and highly advanced digital technology from the 2030s at the exact same time.
Precisely. Just think about the software and hardware challenge of that for a second. You have to maintain two-way communication with completely different eras of technology without compromising the security of either.
That's insane.
It is. By making this failsafe interoperable across both generations, it guarantees uninterrupted mission capability. So as engineers slowly take a Minuteman offline, retrofit the silo, and then bring a modular Sentinel online in the early 2030s, the SLC ensures the overarching command and control network never drops a single connection.
Wow, that is just a staggering piece of engineering foresight. It bridges a gap so the unblinking eye never actually has to blink while this massive deployment is happening across half the country.
Yeah, and it really speaks to the reality that modernizing a nuclear arsenal is no longer just about building a bigger rocket motor or a higher yield warhead. It is fundamentally a massive IT, networking, and logistics challenge.
It really reframes the whole concept, doesn't it?
Absolutely.
Well, to summarize the sheer magnitude of what we've unpacked today for you listening, I mean, we are talking about a project that requires a $2 billion initial capital investment just to lay the groundwork.
Right.
You have a workforce of 5,000 people actively terraforming this defensive network. You have the logistical feat of trenching and laying 5,000 miles of private, ultra-secure fiber optic cable across rural America.
Just massive.
Truly. You have state-of-the-art data aggregation hubs at places like F.E. Warren Air Force Base, and you have the LGM-35A missile itself, which is built with a digital modular architecture that allows engineers to swap out technology in 2045 without scrapping the missile.
And, all of these disparate pieces are scheduled to converge in the early 2030s, and they're operating concurrently alongside a fail-safe bridge that ensures absolute zero downtime during the entire transition.
It is the unseen infrastructure of global stability, entirely modernized for a digital, low-latency age. Thank you so much for coming along with us on this deep dive into the architecture of modern strategic deterrence. We really hope you found the sheer logistics and the structural scale of the Sentinel project as fascinating as we did.
But before we go, I do want to leave you with one final thought to mull over.
Go for it.
It draws directly from the tension inherent in this kind of generational engineering. The source material highlights that Sentinel's modular design allows it to evolve to meet future threats over its decades of service.
Right.
Which leaves you wondering, when you're designing an unblinking 247 deterrence system meant to last for over 50 years, how exactly do engineers conceptualize and build a physical framework today for global threats that haven't even been invented yet?
Man, a concrete and digital framework designed to counter an invisible, uninvented threat. That is wild. It really makes you rethink what it takes to keep the lights on without ever letting them flicker, doesn't it? Well, keep wondering, and we will catch you on the next deep dive.